Hey geometry students, this is your extra practice lesson for lesson 7 in your geometry class. In these videos, what you're going to be doing is sort of reviewing a concept we talked about in class. I'll go through it quickly. You'll take notes in the first part of this handout. We'll summarize our thinking here, sort of what are big takeaways for these lessons. And then you'll have 5 or just a handful of practice problems that you can work on using the notes that we covered in class, using your other peers in your intervention class, and also using your intervention teachers to answer questions. So that's where we're headed with this. First, make sure you have your name on here. Put your name, the intervention period, and teacher, and then your core teacher. So if you're a core math teacher, well, for geometry, we know it's Mrs. Lewis. Just put your Lewis and the period so that we can show this to Miss Lewis if she had questions about what practice you've done, things like that. All right, so let's dive right in. This is a review of parallel lines cut by a transversal. So here we see line AB, and I'm going to make a lot of marks on here so you can see what I'm talking about. Don't feel like you need to copy down everything. Mostly just focus on copying down things that you're going to think are important. So AB and CD, they have these little arrows on them saying that those two lines are parallel. So those are parallel lines. And then EF, I'm going to highlight in green. EF is a transversal. So we're going to be using this basic setup and kind of extending on it in this extra practice lesson today. All right, so hopefully in your geometry class, we talked about these pairs of angles. So corresponding angles. When I think of corresponding, it means they kind of like match up. So when I think of corresponding, I'm like angle A, for example. I'm going to do my corresponding angles with this blue mark. A corresponds to angle E because they're both in the top left, of these intersections. So an example of corresponding angles are those two, and we would write an equation. We would say the measure of angle A is equal to the measure of angle E. So that's one equation. We should be able to write quite a few more because I see other pairs that are also corresponding. So next I would say top right, we'll do angle B and angle F. They're corresponding because they're both in the top right of these intersections. So another equation we could write, do it in the same color, is measure of angle B is equal to the measure of angle F. Awesome. I see two more pairs. I'm just going to do them quickly in black, and you can check them on the diagram. So the measure of angle C, so that bottom left, is equal to the measure of angle G, bottom left. And then one more equation for the last pair. Measure of angle D is equal to the measure of angle H. Great. So corresponding angles, and there are 4 pairs of them when we have a transversal. Alternate interior angles. So interior, I'm going to highlight the interior. Interior is inside these two parallel lines. I'll just label interior. And alternate means sort of opposite, like different sides. So I'm going to erase some of these old stray marks so that we can clean up our diagram. So the interior is in here. So let's say we start with angle C. Do it in blue. Angle C, its alternate angle is angle F. Those are alternate angles. So measure of angle C is equal to the measure of angle F. And then I see one other pair. If we started with D instead, measure of angle D is equal to the measure of angle E, because they are alternate and they're also inside. So in blue, measure of angle D is equal to the measure of angle E. All right. Again, I'm going to erase those marks now that we have those. And then the last one is that the measure of angle, so same side interior, so not alternate, but same side interior angles. So we're still talking about our interior here. same side interior angles are supplementary. So if we start with C again, the same side angle would be E. So supplementary also means that they add to 180. It's a good note to make. Supplementary, so let's make an equation for this. The measure of angle C plus, we're adding them up, the measure of angle E is equal to 180. And there should be one other pair. It's like D and F are same side. Okay, let me fix that. We know that D is the same as F there. So D and F are same side interior angles. Measure of angle D plus measure of angle F equals 180. Great. So those are that's a kind of a recap from your lesson on these terms: alternate, corresponding, same side, and supplementary. Now today we're going to sort of apply these to solve some problems. So let's look at this first example. First, I'd like to pick out what my parallel lines are. Looks like this one I highlighted in red and this one, because they have little arrows, are parallel. And then I'm going to label my, or like color my transversals differently. So I see one transversal here. That's transversal 1. And I see another transversal, I'm going to color it in light blue, down here. So here we see there's two different transversals, so we can use these relationships a couple different ways. So looking at our first transversal, the green one, it wants us to, well, it didn't label it here, but find the missing angles. So it looks like we need to find the measure of angle E, and we need to find the measure of angle F. So those are the two things we're looking for. So I look at this first one, I see, I know 54 is right there. So let's see what relationship 54 has to the angle we want. Well, it looks like we're in the interior here. This is between our two parallel lines. And E and 54 are on opposite sides, so it's going to be alternate. So it's an alternate interior angle. Alternate interior, I'm going to abbreviate that, angles with 54. Well, that means they're the same, so the measure of angle E equals 54 degrees. That one's pretty straightforward. Once we picked out the transversal we're talking about, figured out if we're on the inside, the outside, whatever, and then fill in our blanks. All right, for the next one, I'm going to look at that light blue transversal and zoom in on it here. I see that there's 112 here. That's not in our interior, it's outside. And my F is in the interior. So I don't really have enough information right away to start filling these in, but we should be able to use some of our other relationships to fill them in. I do notice that across from this 120, 112, it's a vertical angle. And we know that vertical angles are equal. 112, so I'm going to label that that's vertical angles. Make my pen a little bit smaller so we can see it. Vertical angles are equal, so 112 across. It's not very easy. And then now we have both of our angles in the interior, and that's what our relationships were. We had alternate interior angles and same side interior angles. So let's decide what this is. 112 and F, well, they're both on this top of this transversal. They're on the same side. Same side. So that means they are supplementary. So if I want to write an equation for that, supplementary means they add up to 180. 112 plus measure of angle F needs to equal 180. We wrote an equation for it just like we did in our first example. Well, this is just an equation. We can solve this. If I have 112 there, I can take away 112. That'll get rid of it so that measure of angle F is by itself. Whatever I do to one side of an equation, I have to do to the other side to keep it the same. And that takes us to arrow. Measure of angle F equals 112. 180 minus 112. Let's see, I need 70 would take me to 182, so I need 2 less than that, so 168. Yep, degrees. So measure of angle F will be 68 degrees. So in that one, we just had 2 transversals. It's kind of extending. In this next example, we're going to introduce something else. So first of all, I like to pick out, it looks like we're talking about parallel lines. It looks like we could have some transversals. I'm just going to extend my lines so that we have a problem that looks more like the ones we're used to. So I extended my parallel lines, and I see that it looks like there's kind of 2 transversals here. So I'm going to extend these lines too. Oh, I want to do that in a different color. I see a transversal here in G. I'm just going to extend it out in green. And then I also see a transversal kind of going the other way. I'm going to extend it out in blue. You can use protractor colored things if that helps you match these up. Okay. So we have 2 transversals. They're intersecting here, and it's asking about some angle at the intersection of them. This doesn't really look like a problem we've worked with, because some information I could fill in, well, maybe I know, looking at 140, its alternate interior angle would be, let's see, this one's on the left side, so this on the right side. These 140 and this angle down here would be alternate interior angles. So I could fill that in if I wanted. Same side interior angles, well, I know that those 2 are supplementary, so this one just next to it, the same side of it, would be supplementary. To get to 180, I need maybe 36. So I'm able to do our relationships here, but they're not really helping me get to this middle one, G. So something else we're going to introduce is called an auxiliary line. An auxiliary line is drawing just another parallel line so we could set up more of our relationships. So I want to draw another red parallel line right down the middle at this point. You should be seeing this either in class A or briefly, and that's called an auxiliary line. Not sure if I spelled that right. It's just another parallel line, and it's going to help us use these relationships that we know, alternate interior, same side interior, to solve for the missing pieces. So looking at our diagram now if I go back to the 144, I see 144 is actually the same side interior angle. It's the same side interior angle as this little one right here. They're both on the left side of that transversal. They're in an interior. Right? This is kind of like one interior here. So those are same side, these 2, same side. That means they're supplementary. So if I'm going to write an equation for this, I'm going to make a note that we're using same side. So it's going to be 144 plus the measure of angle G gives us 180. So all we did is we drew another line, then we looked for our relationships again, and we see, well, this will actually give us part of this angle G, but maybe we'll be able to work on and finish the rest. So subtracting 144. Again, we said, did I say 36 last time? That doesn't sound right. 144. Yeah, hang on, let's double check it. That's 36 for sure. 36 degrees. All right, so we have 36 degrees right there. That gets us a little closer. We don't have all of angle G yet. We don't have the total. We need the rest of it. This part down here. Now if I'm looking at my diagram, maybe I can use this 56 because it's part of that green transversal. So between green and red, I have this one here, 56, and yep, we're in interior. The angle we're looking for is interior to it, and they're on opposite sides of our transversal. So that's alternate interior. So those are actually just going to be the same. So this one, this little blue mark here, is going to be 56 degrees. Now we need to find the total for angle G. Ooh, I see a mistake I made up here. We didn't already find the angle of G. We just found part of it. I'm just going to leave a little x right here. We just found this little x. We didn't find all of it. X is equal to 36. Question mark is equal to 56. And then the measure of angle G is the total of those two. So I'm just going to add them up. 36 plus 56. 30 and 50 is 80, and 6 and 6 is 12, so that would be 92 degrees. So the measure of angle G in this diagram is 92 degrees. And it's always good at the end to sort of check ourselves and make sure that that answer makes sense. I'm just going to erase kind of our stray notes. It looks to me like this angle could be about 92 degrees. 92 degrees. It's less than 180 for sure. It looks like it's just a little bit more than a right angle, 90 degrees. All right. So let's summarize what we've talked about. So looking forward to our problems, it looks like these all deal with parallel lines and transversals. One thing that we did find really important is draw auxiliary an auxiliary line to help find more relationships. Just like we saw in this problem, it wasn't until we drew this line down the middle, this extra auxiliary line through that angle G, that we're able to use our same side and our alternate interior angles to figure out what G would be in total. That's kind of the big takeaway for today. Try out these. There's just 5 quick problems on the back. Feel free to work with other people in your class, and also work with your intervention teacher to help you get there. All right, see you next time.